Welcome everybody. Nice that we have so many people in here. Not do that again.
Can you hear us? No.
Yes. Can you hear us?
Yes! Unfortunately. What? How much is the fish?
As we don't have very much time, we start over. My name is HyperV. I'm coming from Switzerland. I'm working for Architects as a cloud architect.
Can you speak up? Yeah, basically the same thing. No one really cares who we are, so that doesn't really matter. We are talking today a little bit about Windows Server 2016, and there's so much stuff going on, we can't really cover everything, so that's why we choose like 4 big topics to be nano server, storage, Hyper-V, and containers. And we'll talk a little bit about all of this. Oh, that sounds like football goal. So, and since I do these presentations a little in different countries, I started to do also a little bit like advertising Switzerland and tell people a little bit about Switzerland. So we will also like, we have 10 seconds I think to learn something about Switzerland. Yes! Did you bring photos? I didn't bring anything, so yeah. Even in Switzerland we have to look for our money, so
fucking hide everybody else.
So first things first, like I did some presentations in the US. I always have to explain that Switzerland is not really here. It's more or less down here. But it's only CNN, it's okay.
Audience check. Who does know the difference between Sweden and Switzerland?
Okay. So then the next thing, like this is how it looks like when I look out the window. We have chocolate, we have cheese, watches and bags, and that's basically it.
And we have Tom.
And yeah. So this was the quick introduction to Switzerland. Now let's talk a little bit about, first an overview about Windows Server 2016. Like a little bit of an overview. So when we look at improvements in Windows Server 2016, there are multiple areas where Microsoft invested. One of them is compute. Let's think about it as Hyper-V, as virtualization. We will talk a little bit about Hyper-V, what's coming new there, what other improvements here, so I'm not really talking about that. But one thing I really want to cover is that there is still this myth out there where people think, yeah, Linux and other operating systems are not really running well on Hyper-V. That's not quite true. Microsoft invests really a lot of resources to make Linux and other distribution, other operating system of first-class citizens on Hyper-V. They're also trying to get all the certifications and supporting like big applications, like not only the Microsoft internal ones like SharePoint, SQL, and things like that, or they're also trying like third-party vendors, SAP and Oracle software, to certify that it runs on Hyper-V, and as well, of course, it also runs in Azure. Then the next big improvement, and we don't really cover that. It's a huge improvement in the whole stack. It's the networking part, but we didn't really find time to talk about that. So there are several improvements I want to highlight. First things first is that Microsoft really ported the networking stack they have in Azure, which runs in Azure, to the Windows Server, right? So they make all the features, or a lot of features you have in Azure right now, are using SDN, right? They brought features like distributed firewalls, load balancing features, and things like that to the Windows Server as well. One big change also, in the network virtualization stack V1 we had in Windows Server 2012 and 2012 R2, Microsoft was using like NVGRE to do the encapsulation. They also support now in Windows Server 2016 VXLAN, and VXLAN is more or less the default scenario in the next version. But they still will support NVGRE for those things we already have. Okay, I'm not really talking about storage because Michael has a lot of things to talk about storage, like some of those things, storage spaces direct, storage replica, like really amazing features.
Some of those even work.
Yeah, they do, they're quite great. One thing to highlight though is that, again, they also try to like bring this consistency to Azure, right? So they bring us like storage solutions which will drive the consistency to Azure. And then the last part, we never really talked about it for a long time, or Microsoft didn't really talk about it, is security. So security is one of the major investment areas in Windows Server 2016, bringing like PowerShell, security solutions, just in time and just enough administration to the Windows Server world. as well as they bring some features to the HyperV hypervisor as well, which are pretty unique to hypervisors, I guess.
Like the Shield VMs.
Exactly. So let's start with NanoServer. So one of the big things you probably heard of is NanoServer. NanoServer will be a feature or like a deployment option in Windows Server 2016. So NanoServer is there to solve some problems, right? Today, if you look at our data centers and our challenges in our data centers or in our customer data centers, well, there are several. So first, one of the first ones is like reboots. We have to do a lot of patching, which leads to a lot of reboots, right? And not only the reboots, but also the time people invest to automate patching. So we have several customers who spend hours in building automation to patch their systems, their servers, their fabric, and whatsoever, which is quite like impressive. The other thing is server images are too big. If you think about it, basically it's really crazy. If you deploy an application which is 200 megabytes in size, you deploy an operating system which is probably 12 gigabytes in size, just to run that small application, that doesn't really make sense, right? So if you do a lot of deployments, you copy all that like operating system thing through the network, using the network bandwidth, which you can use for other parts as well. And
by the way, the code which runs the hypervisor, the HyperV role, is just a couple of megabytes. So all the rest is like unneeded crap.
So, and then it's also not only that you have like to copy those images, those 12 megabytes and things like that to the hypervisor and do things with that. It's also that it also consumes resources, right? So Windows Server by default also consumes resources, and that's a problem. One thing that's not on the slide is security as well. So if you think about it, if there would be like a huge bug, like a really critical bug in Notepad or in Calculator, that could have an influence on your server, right? Even if you never use Notepad or Calculator on your system, it's there and you have to patch it, right?
So who is still installing Adobe Acrobat Reader on every server?
Yeah, you're laughing, but
of course
but to be honest, I had this one crazy customer who deployed like Java and Adobe Reader on every single server, just by default. So
because it's their standard, right?
And Firefox.
Yeah, Firefox. Well, yeah, you have to do something.
Oh, of course you have Firefox.
There has to be a choice for different browsers, right? So what actually is NanoServer? So let's answer that question. So NanoServer is basically the thing Microsoft tried to have the smallest possible version of Windows Server, right? So what they did is like remove basically everything you don't need and just keep the things in there you need to run the server. So it ends up in like one sentence. It's a headless 64-bit only deployment option of Windows Server. If you think about it, it's a little bit like Core Server, right? You have now full server, or now it's called server with desktop experience, Core Server, and you have NanoServer. There are three options to deploy this scenario. Again, in the first version, it's designed for basically two tasks right now. So one of them is like cloud platform infrastructure, which means HyperV server, storage server, all the fabric infrastructure. And it's also designed for this born in the cloud application, so this ASP.NET 5 application and things like that. So these were the main goals, right, when they designed to NanoServer. But there are other things coming to it. So they also have now IIS running on that. They have other DNS, for example, other roles running on that system. Not only those. Again, as I said, it's following the server core pattern, so like really bringing it down. And this is what I was talking about. So you have this NanoServer option, and you have also like the server core option, which would basically be the standard option. And then you have the server with desktop experience as well. So what will be supported? Again, one thing really to mention here is that if you deploy NanoServer, it won't show up on the ISO file. It's not like you go in ISO, boot up the ISO file, and then choose which option, like full server, standard, or core, or sorry, full server, core, or NanoServer you will deploy, because NanoServer is a little bit different. NanoServer by default has no roles whatsoever on it, right? So you have to create your own image basically first and add those roles and features and drivers even to that image. I will show you that, I would like the commands a little bit, but not a lot, because we don't have time for that. Again, as I talked, Hyper-V, storage, clustering, all those things are in there, and Microsoft is adding more of them as well. The good thing, we have full Windows driver support, so all the drivers which are working with full server or server core will also work, should also work with Nano server.
Except the graphical ones, of course, because you don't have the UI.
Yeah, and everything which you install with MSI doesn't really work there because you can't use MSI on a Nano server, that won't work. You still could like extract the MSI and like take the files out and put them on the Nano server, but that's one thing. Then there will be anti-malware built in, and they also have System Center and Operations Management Suite agents which you can build in to monitor, to back up, to like manage them as well. Okay, how does that look like? Now I will show you that quickly then. So services improvement, so this is a study Microsoft did where they compared in 2014 if Nano server already would have existed, what that would mean for the scenarios here. So we have Nano server against core server and against full server, and in terms of patches. So, well, interesting, there are two things, like the critical ones, I think that's very interesting. So we had only like 2 critical like bugs in there for the Nano server. And the other thing is like patching, right? So a lot less reboots for those patches. So that's basically it. Still, little side note here. This is only for the basic core or for the server core thing. If you add a role, for example, IIS or Hyper-V, and there are bugs in Hyper-V or IIS which has to be fixed, right? You still add probably some more reboots to that system. Okay. Then the other thing which is really impressive, and I'm going to show you that a little bit on my notebook here, is deployment time. So this time we only compare it to server core. When you deploy, for example, a server core server to a system which takes 300 seconds, with Nano server it took like 30 seconds to deploy that, which is like a huge improvement if you look at it. And even if you look at disk footprint and VHD size, so for the virtual disk size, a full server today needs around, I think, 12 to 14 gigabytes in size. If you look at Nano server, a VM could be like 400 to 500 megabytes in size. Right? So that's a huge difference. If you think about copying that, it takes a lot less time. Okay, so this a little bit about Nano server, and I want to cover like this one feature in Hyper-V or like several of them. So in Hyper-V, one of the biggest things that's coming is like shielded virtual machines.
And it's not only Hyper-V, every hypervisor. If you're the admin of the hypervisor, you're king, right?
Yeah. So the biggest challenge, well, the thing we did in the past is we really did protect our Hyper-V or our virtualization infrastructure from the bad guys inside a VM, right? So that was what we did, right? So we tried that they can break out of a virtual machine and throw in our fabric and go to other virtual machines. But who did protect the guy inside the VMs from us, our administrators, right? If you're a Hyper-V or VMware administrator, you basically got access to everything, right? So you just copy the VM, open it up, open the VHD, you got all the data from the customer or whatsoever in there. Same applies also to the storage administrator. So the storage administrator gets access to all the files, VHDs, etc. Can access those because they're basically most of the time not encrypted. And also the networking guy who can, if the network traffic is not encrypted, he can like see that as well. So Microsoft is addressing that. And there are several features that are included in shielded VMs. But this big topic, one of them is virtual secure mode. So virtual secure mode addresses that the Hyper-V administrator really can't access the processes and the memory of a virtual machine, right? It protects the memory of the process of the virtual machine itself. The other thing is the host guardian service, and this really has one thing to do, and it looks that the VM only starts up when it's on a trusted hardware, right? If I give a virtual machine to Michael, I only want the virtual machine to run at Michael's servers and not somewhere else, right? So if he gives the virtual machine away, it's basically useless to use it. And the last one, which is basically name shielded VMs, is BitLocker support coming to that. So you can run a VM using a virtual TPM chip inside a VM and encrypt those using BitLocker. So in that case, even if I got access to the VHD file, I can't really do anything with it.
The only thing you need for full support of those features is the TPM 2.0 chip in your hardware in your box. When you're running HyperV.
So this is special because not a lot of servers already today have TPM chips, but I think with Windows Server 2016 we'll see a lot of servers going out there with having TPM 2.0. So then we have some other improvements here. We finally got hot add of network adapters for HyperV virtual machines. Yeah. That's impressive.
Every one of you is adding all the network adapters to their VM.
Yeah,
yeah, that's what I would say.
No, the biggest drawback here is there's a maximum, right, of 8.
Yeah, so you have to remove them and add them again.
Yeah.
So,
Yeah, but it's annoying. It's a limit, I feel.
Yeah. No, this was it always when I talked to VMware admins. This was one thing they all said: why you can't add network adapters to things? Yeah. Okay. So we can do that now. We can also now do online memory resizes, so we can add and remove memory on the fly.
Which is cool. Much more.
Yeah. So
value than adding network adapters.
Some people may remember the feature dynamic memory, which is still in there, which allows you to set a minimum and a maximum value of a virtual machine, and it can go up and down. This is kind of different. So dynamic memory was good, right? Especially in VDI deployments, this was like a huge impact. But still, like when you use dynamic memory, you lose some features like virtual NUMA, virtual guest NUMA with memory features. If you use static memory, you still have those features, and you can now resize the memory. We got PowerShell Direct, which allows you to connect to a virtual machine using PowerShell Remote in without accessing or having access over the network. So you can directly go from the HyperV host itself using the VM bus inside the virtual machine using PowerShell Direct. That's something. So, for example, some customer disabled the network adapter, you can just run a script on your HyperV host to enable the network adapter inside the virtual machine. And then we had this new thing, cluster rolling upgrades, which is pretty cool. So, who was updating Windows Server 2008 HyperV clusters and beyond? Like, was it nice to do?
4 years ago.
Not really. Yeah. So was it nice? The upgrade with HyperV was always a little bit painful. And one thing was that you always had to create a new cluster and then migrate the virtual machines to that cluster. There were like live migrations you could do in 2012 to 2012 R2, but still you had to build that new cluster. You couldn't do a mixed mode. Now with 2016 you can do a mixed cluster with 2012 R2 and 2016 nodes, and then replace all the 2012 R2 nodes and upgrade all of them to 2016. So like doing an easy upgrade process for your clusters. And again, as I said, we have a lot of changes in the software stack, and also some huge improvements in backups and checkpoints, like production checkpoints, which means production snapshots. So you can do now like snapshots or checkpoints of a virtual machine in production. Yeah.
Very quick question. You talked about the protection from the HyperV host to the virtual machines, but then you have this PowerShell Direct.
Yeah.
How does that?
Yeah, but you still need a local administrative credential inside the virtual machine to connect our PowerShell Direct. So it's
absolutely. So you protect the VM, and you still need credentials. Of course, you can't just go in there and do that. And of course, there are a lot more improvements to that. We can't really talk about all of them, but there's a lot more. So let me quickly show you two things in a demo. Again, we don't have a lot of time, so I'll do it really quickly. By the way, this is the new icon of the HyperV Manager, which was released in the latest Windows 10 Insider preview. So you see there are some new icons in there. Just looks more fancy now. Thank you. Wow. Normally I expect a little bit more flowers, but okay.
But the color, I think the color is good.
Yeah,
I mean, it's green for colorblind people.
Yeah.
It's Azure, right?
So yeah, it's Azure Green, Azure Blue, whatever. So what I have here is I have a virtual machine here, and what I want to show you here is that I can log in with this virtual machine.
Really?
I can. And one feature I really want to show you is the hot add memory feature. So you see that I have like 1 gig of memory. I go now to the settings of the virtual machine. And if Server Manager doesn't like steal me the show here, it will be fine. What you can see here, I can go to like memory and it's not grayed out anymore. So I have like 1 gig of memory. I can now say, okay, I want to have 2 gigs of memory.
You just tweak the UI that is not great.
4 gigs.
Yeah, I don't have enough memory here for my notebook, to be honest, but yeah. So you can see I changed it on the fly, and of course, I can also change it back, and you will see, I think there's still there's a bug in Task Manager, I think. So I will change that. And if you look at the UI, it still says 2 gigs of memory. It says here 1 gig of memory. So I reopen Task Manager, and I think it should go away.
That's detailed.
So just to show you that bug here, so it's 1 gig again. So I can report that and remove those features.
There are other bugs.
I see it's catching up.
So one thing I really want to show you is Nano Server. So there's one thing. So I have this Nano Server VM here prepared here. So it's not shut down. It's just it's not even installed yet. So it will do like an install using an unattended XML file and boot up. And because I still don't have a lot of time, I still can do that because you can look how fast it really is. So it's doing now the installation. It's like a suspect VM and that's done. But this was basically the installation from an unattended XML file.
But you have to create the installation achievement.
Yeah. So I prepared an image, a VHD, and then booted it up.
Which takes about 2 or 3 minutes to prepare the image, to then attach it to the hardware or VM, boot from VHD and
Yeah. So I said that there's no UI. It's not exactly true. There is a little bit of UI, and this is not really a login to the server. This is a login to the recovery console. So there's a recovery console where you can log in.
all of you know very well the ESXi concept of the recovery, or let's say, how to call it, management console? No. Emergency console. However, this is the same concept.
Yeah. So I'm logged into that, and then you can see I can't really browse any file system or anything. I just can like do some look at the configuration, reset the networking and things like that, open firewall ports and things like that. So that's the only thing I really can do when I open up the console. Everything else with Nano Server is remote management. Right? So I use MMCs, use PowerShell remoting, use Server Manager, and all those things to do that. Okay. So let me quickly go back to the slides because Michael has some great things to show you about storage.
Yeah. Storage, software-defined storage.
Just a quick question. Can you install third-party Windows service into the Nano Server?
Yeah. So the question was if you can install third-party software inside the Nano Server. Yes, you can. It's mostly like the application should be designed for Nano servers. Not all Win32 apps are working on Nano Server, but a subset of them are still working, even with Nano Server.
Storage Space Direct is basically the on-premise version of the underlying storage technology of Azure. So you can compare it in some ways. So it's storage spaces as you know it by today, but instead of plugging 2 or more servers together with JBoss over the SAS bus, you just plug in local disks into the service. You can combine it, or you can compare it to VMware vSAN from the concept side of point of view, or you can compare it to maybe Nutanix in some way. It's just nodes with local disks connected over software, which is called Software Storage Bus, lives in Windows Server 2016. So you aggregate local disks into a failover cluster, you connect the disks over the clusters using SP3. That's basically the magic. Scenarios. There are 2 main scenarios. Hyper-converged. And here usually people yeah, finally! But nobody,
Yeah, finally!
oh, thank you. Hyper-converged is way cool for small and medium environments, in my point of view. Because you have one huge issue here. Instead of microphone, you have an issue that if your compute layer, like memory CPU, and your storage layer does not scale at the same level, you add compute just for nothing, or you add storage just for nothing. Okay, so if you have to add 10 terabytes more storage, and you're out of capacity of your local disk shelf, then you add more nodes, just to have more capacity on the storage. But there is another way. We can do it traditionally in a disaggregated model. So we use the storage space as direct scale-out file server underneath the HyperV failover cluster, as we use it today. But the difference here, there are no JBOS, there are no SAS cables, no MPIO stuff, no SCSI reservation, hell, nothing. You can use basically SATA disks inside here. So your storage configuration gets a little bit cheaper than you are with enterprise SAS disks. And you can scale up, of course. You can scale up from 4 or 3 now, you can scale up to 16 nodes per cluster. The software storage bus is a piece of software living in 2016 server, and it has basically a concept of local cache by host and some capacity devices. Every host has at least 2 caching devices and at least 6 capacity devices. Depending on which mode you choose, either all flash or mixed with HDD, there are some differences in how the cache works. I'm not going through these differences right now, but let's say in a year we are not using HDDs anymore. We can see it right now. The project we are planning for customers now with TP5, they're all flash. So HDD is still there, but it might not be the right case, right? So this is not a backup solution mainly. This is a solution for performance, for VM storage, database storage, where you need really performance, where you can start small and scale up. That's the concept. With software storage bus, they have added 2 main components. This is the class port driver and the class filter driver. The class port driver acts like a virtual initiator for the SCSI devices living on other nodes. Question?
Slide before.
Slide before.
Okay. Capacity devices and caching devices limit?
Limits?
Yeah. How many capacity devices I can have?
How many you can stick in your box?
Yeah, is there limits or not?
No.
No software limit?
No. I mean, there are limits in total number of disks per cluster. But as it was with SAS, in a number of 80, this has very much increased now. So the 80 disks per scale-out file server cluster is not anymore there. I can't tell you the final number, but it's higher.
Same for caching devices?
Same for caching devices. If you have tons of PCI Express buses in your box, you stick in as many caching devices as you want. The cool thing about mixing different types of storage is the 3-layer architecture. So you have cache, but then you have those virtual disks. Still, you have your storage pool, which is spread all over your storage nodes. Then on this storage pool, you create virtual disks. Now, with the Server 2016, you can create such as multi-resilient disks, meaning a single volume can have a mirror tier and at the same time a parity tier. Because mirroring, as we all know, is the least cost-effective option. It's incredibly performant, but it's not very cost-effective. Now you can mix those tiers in the single volume, and the magic here is somebody might have heard of erasure coding. Microsoft is using local LRC, local reconstruction code for the erasure coding mechanism. So they are really more effective if you have more nodes. The more nodes you have, the more effective your parity tiers become. So we can mix fast and almost fast tiering on the same volume. But that's not the last thing. The most coolest functionality I really think of is real-time tiering. If you have to move data from a slow tier to the fast tier, or vice versa, most products or vendors, they do a block copy mechanism. So once a day, or 2 times a day, or somewhere in the day, they are copying, regardless of the heat map table, they are copying the blocks which should be hot to the fast tier, they are copying the blocks which are not really being accessed frequently to the slow tier. So this has some disadvantage. Imagine a database server or a large query You have to get the performance right now and not 8 hours later. Because 8 hours later, your workload is already finished. And then when you need the performance, you have it with real-time tiering. It's not block copy. We will talk about that in a minute, what happens if they tier. Typical configurations. Question was how many devices? Typical configuration is 2 caching devices per node and as many capacity devices you want or you're able to stick in the node, right? You can have cache devices, NVMe devices, you can have cache devices using SSD. The fastest way is, of course, you plug in NVMe devices sitting on a PCI card, PCI Express card, and you stick into the PCI Express bus. Then you add SSD disk and for capacity HDD disks. You can do that. Or if you want to have more performance, then you stick NVMe and SSD only. But still, you can mix mirror and parity tier to gain more effective usable storage from your raw capacity. Or then you just use performance tier. This is the ultra fast way. We will see in a minute what ultra fast means. What are the requirements? 3 to up to 16 nodes per cluster, 10 gig or higher. RDMA is requirement, it's not recommendation, it's a requirement. So you have to either use Mellanox, Rocky technology or iWork from Chelsea. These are the 2 possibilities you have. 2 caching devices I've already mentioned. A minimum of 4 capacity devices. It's 4, it's not 6, it's 4. And the storage controller where you attach your local disk must be in HBA mode. So no RAID controller, no RAID pass-through stuff, just a simple SAS controller with the expander where you plug in the SATA drives, right? And certified hardware, of course. Question?
HBA, the HBA mode actually exposes the smart for hard drives, etc. If the smart starts showing that a hard disk might fail, predict fail, will it take some actions?
Yeah, there's a storage health service in 2016 server which informs you that you might have a problem with your SSD drive within the next 10 days, whatever. There's a storage health service taking care of smart data living on the physical side. Storage spaces, direct partners, this is the list. I can tell you that these and these and these and these are very advanced in the process of certification. That's all I can say. What I'm showing you right now, the demo equipment is based on Quanta compute servers. It's this model, a 2U unit, 2 high unit, with 24 slots for local disks, and we have 64 gig of RAM, 2 capacity devices, NVMe with 800 gig, and 2 12 1 terabyte SATA enterprise disks from Samsung. All of the stuff costs you about 75,000 euros for servers with 21 terabyte usable storage. Of course, this is important, as I said. Now, in this configuration, we are using a 40 gig configuration with Mellanox card and switches.
I thought it would be 100 gig, but okay.
I'm sorry. The switch is 100 gig, but the cards are only 40. So we're running at 40 gig. So let's see how this looks like. What I'm using here is a tool from Microsoft called VM Fleet. It's like a standard tool living on GitHub to test your storage performance. The 4 nodes are in the storage space direct hyperconverged configuration. So all of the 4 nodes are storage nodes and compute nodes. Every node runs 10 VMs, and I'm going to start the whole fleet of 40 VMs right now. So what we see is a typical boot store with a lot of reads. And as the VMs boot, they start inside the VM, they make an auto-login, they start the disk speed with a pattern of 4K block size, all random, with 90% read, 10% write. That's actually the workload they are running. So what we see is more or less 500,000 IOPS with a decent number of latency for reads as well as for writes. For 75,000 euros, 20 terabytes of disk performance.
You cannot buy Tesla.
That's all. And if I would leave this 2 days, it would be stable for 2 days. But what we can see is that CPU is becoming more and more important. CPU is the limiting factor in this configuration because we don't get more than 500,000 IOPS. Because every node with every core is running at its limit.
Is this your home setup?
Unfortunately not.
Yeah, this is where all the money, this money goes, is in storage space and hardware.
So, there are other things. REFS. REFS is the default file system for those type of configuration. No more NTFS. You can still use it, but you don't benefit of this real-time tiering between performance and parity tier on REFS works. Because what REFS does, it's not only resilient, self-healing file system where you don't do any disk checks anymore. It's also, on performance side, a complete new concept. It has a metadata layer where in the real-time tiering example I gave you, they are not copying blocks from fast to slow tier and vice versa. They're just moving the pointer on the metadata of the volume. So they just say these 10 data blocks, they are not laying on the performance tier anymore. They're on the parity layer, and they just flip the metadata pointer to the other tier on the same one, which is incredibly fast. But not only this, everyone's dealing with checkpoints, right? Either you do backup products, use backup products which are based on checkpoints. You merge checkpoint, which is maybe hundreds of gigabytes because someone forgot to delete the checkpoint, and then you have to merge it. On REFS, it's not copying, it's just block repointing on the metadata layer, which is more or less 25 times faster than every disk copying process. Also for creating fixed disks, if you create on HyperV, you create a fixed VHDX with 5 terabytes of size, you're gonna wait a long time. It doesn't depend if your SAN is incredibly fast or not, you wait hours, if not days. If you do that on REFS volume, it's like 5 terabytes. Storage replica. Asynchronous or synchronous replicate volumes on your cluster to another cluster, or on your cluster which is stretched over 2 days. That's basically it. Synchronous or asynchronous. It's on volume layer, so the source volume and the destination volume can be any volume of any type. Doesn't matter if it's a SAN volume or a local disk or a storage basis, a virtual disk volume, whatever. Those two scenarios we have with storage replica built in.
And you also have server to server.
Server to server, yeah. If you want to do single server mirroring of volumes, that's also possible. Some facts here: under 5 millisecond round trip on your network for synchronous mirror, which limits your data center distance, let's say up to 100 kilometers, more or less. Then RDMA is a recommendation, identical source, volume size, and destination volume size, which makes sense, of course. That's basically it. Containers. Last.
We have like 30 seconds for containers. So I'm going to talk really fast, okay? So no, well, when Microsoft really started to talk about containers, the first thing I did, I was like going to Wikipedia and like, what was containers? Because containers were there before, right? It's not something Microsoft invented. And then I looked at it and thought, yeah, okay, still have no idea what it is. So, but there's one word that's really important and that really helps. It's operating system level virtualization, right?
You got the same wiki line I copied.
Ah, nice one. So by the way, since I don't have a lot of time and and otherwise. There's a very good session about containers on Sunday morning, right? So look out for this. But I still want to show you like 2 minutes about something like containers. So again, operating system level virtualization. If you think about VMware or HyperV, what we did was virtualizing hardware, right? So we built virtual hardware, and with containers, we basically to build virtualized operating system containers, right? So we don't do virtualized hardware. So if you look at this, what we did like in the past, this bare metal deployment where we installed the operating system on physical hardware and then installed apps. When we looked at virtual machines, what we did, installed an operating system, had this hardware virtualization layer, created virtual hardware, installed an operating system, and installed the apps in there. And we could do that, of course, multiple times on the same server. Nothing really new for this audience here. And then with containers, what we do is basically install the operating system and then create those containers, these virtual containers, on the operating system itself. This can run on physical hardware directly, or the thing which I see more is that we still create a virtual machine, install the operating system, and run containers inside the virtual machine. So that's also possible. That's basically the things we do. So,
Okay, can you go down?
We are not allowed to say more because we will fuck up his session.
No, but you know, this scenario left. You know, the most people which run containers run it in Azure or in Amazon Cloud or whatever, and they don't get hardware. They get virtual machines. So you have to use them.
So this would be I think this would be the main scenario. So you can also combine those, and then you get like best of both worlds, like things like that.
HyperV inception.
Yeah. So this is the next one. I hope we're not going too deep. I'll just skip that one. One thing to note here: Microsoft did not only Windows Server containers; they also released HyperV containers. What they basically did is they built those like VM isolation they had for virtual machines around the container, right? So you get this extra level of isolation to the HyperV containers. What you need for that is HyperV as a hypervisor. And if you think about the scenario before, where we were running containers inside the VM, that means we need Hyper-V inside the VM. This scenario here. So we have Hyper-V on the physical bare metal, and we have also Hyper-V running inside the virtual machine, which gives us a little bit of a side effect and gives us nested virtualization. So we can now run the Hyper-V inside the virtual machine and run a VM on that one as well. So
Finally.
VM inside. Yeah, that's fine. Yeah, right. There was applause for that.
And the performance is...
Yeah, great. Yeah. So if you did...
This is production ready.
This is production ready, yes.
Absolutely. If you compare it to other hypervisors, when you did like nested virtualization, this is like what you can see right now is like really, really good. Okay, this was basically it. There's one more thing. I totally forgot about that. And that's probably the most complex thing ever. Licensing. So they changed just two things to remember, and I'm not going to explain everything. So we're going to change from a socket-based licensing to a socket and core-based licensing model. So basically, if you have, what you have to remember, if you have 2 sockets and more, a socket has more than 8 CPU cores, physical CPU cores, you have to buy extra licenses to do that. So this is one thing. And then there are also like 2 editions, standard and data center again. And like in 2012 and 2012 all the features were like in both editions. That's not happening anymore. There are features like storage spaces direct, like storage replica, shielded VMs, which are only in the data center edition. So those are 2 things to keep in mind with licensing. So with that, if you want to talk a little bit more about that, we were outside. We can talk about Windows Server like forever until probably 10 minutes, but let's go.
Thanks, guys.